Hello everyone, welcome to Lectures by Aparna. In today's video, we will discuss three matrices: Toeplitz matrix, Circulant matrix and Hankel matrix. Another name for Toeplitz matrix is diagonal constant matrix. Diagonal constant matrix. I will show an example for Toeplitz matrix. This is a Toeplitz matrix. A Toeplitz matrix may or may not be a square matrix. In this matrix, you can see that each descending diagonal from left to right is a constant. That is, all elements in a diagonal are same. Descending diagonal from left to right is this one. This is another descending diagonal from left to right. This is another descending diagonal from left to right. And this is another descending diagonal from left to right. Those elements coming in the descending diagonals, they will be constant. So here this 5 and this 5 will be same. Now in the next diagonal, this 1, 1 and 1 will be same. In the next descending diagonal, this 2, 2 and 2 will be same. So likewise. Now let us see how we can write a Toeplitz matrix. I am going to write a 4 by 5 Toeplitz matrix. 4 by 5 means I will be having 4 rows and 5 columns. So now let us write a 4 by 5 Toeplitz matrix. Now I am going to fill these blanks. I am taking random numbers. First I am taking a 3. Now I have to fill this 3 in this diagonal. So 3, 3 and 3. Now I am taking next random number. I am taking number 6. Now I have to fill this diagonal with this 6. Next I am taking a number 1. Now this diagonal will be 1. Next I am taking a number 4. So this diagonal will be 4. And I am putting a 0 here. Next I am choosing a number 5 here. I have to write 5 in these two places to make it a Toeplitz matrix. So 5 and 5. Next I am choosing a number 2. I have to fill this position with number 2. And I am putting number 8 here. Now this matrix is a Toeplitz matrix. You can see that these descending diagonals have become same. So this is a Toeplitz matrix. Circulant matrix is a particular type of Toeplitz matrix. Circulant matrix is a square matrix in which each row vector is rotated one element to the right relative to the preceding row vector. I will show how to write a circulant matrix. Suppose if I am writing the first row of a matrix as 5, 9, 8, 4. Now in the second row, I have to shift this first row to the right by one position. So it will be 5, 9, 8. This 4 will be coming here. In the next row, I have to shift this row again to the right by one position. So it will be 4, 5, 9, 8. This 8 will come here. Now again in the next row, I have to shift this row to the right by one position. So it will be 8, 4, 5, 9. So I got a 4 by 4 circulant matrix. You can see that the descending diagonals from left to right is a constant here. Descending diagonal means these diagonals. So all elements coming in this particular diagonal is same. In this particular diagonal is same. In this particular diagonal is same. So the circulant matrix is a Toeplitz matrix. To be a Toeplitz matrix, the descending diagonals from left to right should be constant. But a Toeplitz matrix may or may not be a square matrix. Circulant matrix is surely a square matrix. So this is what circulant matrix means. Another name for Hankel matrix is catalecticant matrix. Hankel matrix is a square matrix in which each ascending skew diagonal from left to right is a constant. I will show an example of Hankel matrix. This is a Hankel matrix. It is a square matrix. In this example, it is a 4 by 4 square matrix. The condition to be satisfied for it to be a Hankel matrix is that ascending skew diagonal from left to right is a constant. Ascending skew diagonal means these diagonals. All elements coming in these diagonals will be same. So this 4 and 4 is same, this 9 is same, 8 is same, 7 is same, 5 is same. So any matrix in which elements come in this way, it will be a Hankel matrix. So this is a Hankel matrix. If this video has helped you, please do subscribe to my channel. Also don't forget to like and share this video. Thank you.